we remembered that we could change the display of the robots and the color of the lights behind the buttons. And that gave us the idea that we should do a light show in the dark. And we moved over we moved over here because there's windows over there, and therefore it wouldn't be dark.
And so I had to move all the tables to the walls and move it around so there wasn't a lot of light.
I had to come up with a design for the robots.
I had to carry out that design. We all sort of made the robot. Since there's 6 of us, we sort of helped each other because we can't all have a robot. And then we basically, because with the different things like you said, wave and dancing, we sort of incorporated it all into our project. Just a little bit of it. It's like about 10 seconds. Yeah, and then for programming, we used, like you said earlier, display, and then the lights underneath the brick buttons, just to give it a little more flair.
What were some of the difficulties that you had that you didn't really see, and how did you overcome those difficulties through your design process?
To space them evenly, and if they were at a slight angle, they would run into each other, or because, well, in the show, they sometimes hit each other if they're not positioned perfectly, and so they're always one robot apart.
Tell us how you worked as a team. What did you do as a team so that everybody had a say in the decision making and all of that stuff? Tell me a little bit about. And I know it's a short you just met today as far as a group, and how did you decide who does what, whatever? How did you decide that?
We sort of, when we were thinking of the idea of what we wanted to do for a presentation, we all sort of had different ideas, so we thought, why not do a little bit of all of it together so everyone gets a say. And then we sort of just came by of how the design of how we want the robot to go. We wanted it to be a simple design for the robot, nothing too fancy, so it is just a simple design. We all helped building the robots. And then for the layout of how the dance and the presentation goes, we all sort of thought of what's a simple way to make it look good, but it's easy.
What's in your program? What's the green line for?
Oh, just so we know where to set them up to make sure they're even.
So they're
otherwise,
all even across.
they
With no
won't.
sensors? I'm just curious.
Okay, there you go.
Go ahead and check the lights.
I just put the green line.
how this came to be.
Yesterday, me and Dallas, we came up with that design, and it worked really well because it was really simple and there's lots of room for modification. So we thought if we used that design again and slightly modified it, then it would fit the standards for today.
So then we split it to two groups. One were building it and the other was going to program it. So everyone built it and then they all programmed it.
The problem with it is usually if you get it going, it'll go good for a little bit and then it'll start veering off just a little bit, and if it goes for quite a while, just a little bit can turn into a lot.
Some problems we had when we were building was some of the robots just kept on going and wouldn't stop.
Some of the problems with the programming was that, my program, I couldn't even get it to start. It just did one rotation, and I kept on checking everything, and everything was fine. And eventually, I just had to start a whole new program. While Dallas designed the program that we're going to be using.
Some of that, the first one was weird because it had a problem at first, but then when we fixed it, we still had to submit it anyway.
We had a little problem with the structure of it, like it kept breaking a lot. And so we fixed that kind of. We added supports
Here, to keep the wheels from spreading apart when it was driving forward.
Tell me a little bit about how you decided who was going to do what. How did you guys come up with that?
We figured that, say, me and Braden were better at programming than we were building, and then Cole was better at building than he was programming. We had whoever had more of a skill at building or programming. That's where they kind of got fitted into their position.
So you guys all mentioned a bunch of problems, but what's good about it? What are the positives of what you've designed?
We got it to use echolocation stuff, and I know that's a skill from earlier in the week, but really it's only starts to think about it because it's the only sensor that we used.
The fact that we used a design from a previous day, and then we made slight modifications, and it still worked under these standards and things.
All right, let's see it.
Okay, everyone, finger on a button. The sixth person, take here. You can just take that button.
What's it going to do, guys? I don't.
It's gonna go down, and then the first one's gonna stop, and then they're all gonna stop in.
You just follow them.
Okay.
3, 2, 1, go.
And stop the That didn't really work, but okay.
It is exact. That's what I was meant to do. It was close to that.
Try it. Did you get it to work? Try it again real quick. We can do it real quick.
Are all the ports in the right places?
Yeah, the wire. Yeah, wire was in the way.
Remember, with your hands and things, it can pick up other things around there. So if you're using colors, it's going to pick everything up.
Go.
Say we wanted to build a simple robot, but we built it step by step. And if you had an idea, we would all agree if it was a good idea and we would do it, and then we came up with these designs.
And then when we were programming, we decided that we needed a simpler way to start than to click the buttons, because the buttons sometimes can't be accurate. So we used the touch sensors. So when we clicked the touch sensor, it would start instead of like clicking the correct buttons.
For our program, what we did is the hard part was getting all the timing right, because we made a star for our robot show, and so we had to get the right timing. So we made a diagram of how far you go and how long you wait, to make it easy to stay as a team.
Some of the problems on the way were when we were programming robot number 3, the whole computer just shut down and we were right about to finish, so we had to restart the whole program.
Some problems we had when we were building where we couldn't get the gyro ball to go on at first, but then we figured it out and designed it.
Another hard part was to get all the robots that were parallel to each other exactly pretty close to exact the same.
So it's gonna, can you get that diagram back up? So what's actually gonna happen?
So what's going to happen is that all the robots are going to go to their positions in a star pattern, and then and each one is going to come into this to that red dot. I don't know. It's going to be close to it, and they're going to do a unique. Well, not so. Do something like a dance or something.
A freelance after that.
And then they're going to come back out to their original spot.
So how did you guys decide as a team who does what? How you're going to do it? Tell me a little bit about your
We
method.
all just kind of came in with an idea, and then we just troubleshoot and see which idea would overall work and be the easiest, but still look cool. And we decided that in the end we should do this one.
To keep it easier, when we go in the middle, we decided that we each get 5 seconds to keep the timing right. So you go in, then you have 5 seconds to spin around or do whatever, and then you have to get out before the other person comes.
But 2 of them get kind of close to each other, but they don't hit. Well, by all the tests we've had, they don't hit.
We also had to lay down tape where our robot starts so that we get it perfect every time, and it's exact when we start.
All right, let's see it.
No, still no!
Jason was still talking.
1, go.
Never know.
That was still explaining.
Mine's on 7.
If you could have seen, some of the robots have displays.
Pretty cool.
Talk about what you've done and your design and what's going to happen here.
I kind of made the structure of the outside of it and all the wiring, and then everyone else copied it and did the ultrasonic and color sensor, and the other people also did the programming.
Tell us about how you decided the decision making and how you came up with things.
We came up with this idea because it was the cheapest. We looked a few days ago. We saw a robot with the 2 motors and the brain, and then we had 5 robots, and we didn't really have enough pieces that we need for advanced robots. So we had to pick the one that we can modify, but yet still do what it's supposed to do.
Yeah, what he said, we started with the basic bot, and then we put some stuff on it, and we arranged it in the programming.
The one with in the front, now it's appeared in the nose because it's got the black thing on top.
And credit goes to Mr. Buddy for making us this simple design.
We have a problem with color sensor and where it works.
So what's it going to do?
Well, it's gonna do fog later, and the first one's later, and that one will stop at the red line. All of them will stop right after that stops.
All right, let's see it.
Hey, guys, you're second.
Okay, go to your robot. Try to get the color sensor on half brown, half white. Try to get half brown, half white.
No, it's programmed.
Guys ready? Remember, when you hit the button, it activates.
3,
You don't want anything in front of it.
2, 1, go.
Oh, no, no, no. Spikes down. Oh, the color sensor's not even working.
Ready? 2, 3, 1, go! I think I counted wrong.
Yeah, you said 2, 3, 3, 2, 1. We made it go too long. We made it go like 11.
Basically what we did was made 5 of the same robots, have them on all in the same program and dance kind of symmetrically to each other.
Okay.
That was the first step. And then we kind of like thought of a cool, the middle one, we wanted to add a flag. So we added a flag and we just changed the programming. So we added a little line to it for a repeater that it going back and forth like a flag. And that's how we added that.
We had to do dancing, so we picked music. So I picked Eye of the Tiger, and because I love 80s.
Okay.
And then I started being the DJ, put it on.
All right. Tell me how you made decisions as a group. How did it all formulate as far as you guys deciding what you're going to do, who's going to do what, all that kind of stuff?
So we all kind of had different skills with the robot. So some of us did the programming, some of us built the robots.
Yeah. And the other of us made plans for the robots and programming and had us discuss it to see how we would do it, and then we would do what we planned. And the first programming that we did was just to make sure that it worked, and it did work, so that we worked our way up the ladder.
Lastly, the last question I got for you is, as you were going through that, you obviously encountered some problems. What did you do and how did you figure out? What changes did you have to make as, what were some issues you didn't foresee as you were doing this?
Well, the main problem was when it was turning, it was getting off the angle, which when it was going backwards, it just kept going all over the place because the turning wasn't right. So we basically fixed that, and it's like one of the only problems we had.
And sometimes when we were practicing, some people would start late pressing the buttons. So also we added this button to help us press it.
Yeah, this out here, so it would make it a little bit more even and it wouldn't push it back, because that was a big problem. There would be press, it would push some of them back, and so we added this to help it.
Okay.
All right, let's see it.
Vicky, Cliff, and Peter, come on over here.
I want to ask you some questions here.
Okay, why don't you guys tell us about your robot? What's going on? What's the process? What are you doing?
We're doing a line follow the line project, and basically we're going to start this one, and then 10 seconds later that one's going to start, and it'll just keep on going on like that. And
Obviously, you guys had some problems and things. Tell me a little bit about your team and what you did and how you did it.
So first of all, the first problem was we couldn't find out a design for all the robots that would work. A second problem we had was the program, because we were all confused on what we wanted to do if we wanted.
And it wasn't downloading.
Yeah, and it wasn't downloading.
but we finally got it just to practice. The reason we only have 4 robots is the battery died.
Okay.
Sorry.
Anything else you want to tell us about anything that you did? What were some of the problems that you had to fix, that you had to overcome, or anything like that?
No. We couldn't find the right parts for a lot of the robots.
Yeah, and it was like right when the sandbox was being picked up, so.
All right, let's see what you got.
All right.
That was good.
All right.
Well, our bot started off with an ultrasonic sensor on the front instead of a touch sensor, but we started having issues with that because the ultrasonic couldn't fit on the side that the color sensor was on, so we ended up switching to a touch sensor. And it turns out it works better. We had to make sure that we had teamwork when we were building the robots because there were 5 different robots that we had to build, and we wanted to get them built as quick as possible so that we can have more time to program the robots, overcome any challenges that there are, fix any problems. And so what we did was we came together, we had one robot, we built it, and then we just had all the others get built just exactly like that, one example.
And then we also started out by following the difference between these lighter tiles and the darker tiles, but then we found out that there wasn't as big enough of a difference there, and so then we just switched to using this red tape as a line. It was just simple.
I've got all different experience on here, from robots that just be starting and roboter to guys on the robo team. How did you decide who was going to do what? What did everybody do? Tell me a little bit about what y'all did.
So, I was the chef. So, Peter did some of the programming, and so did Spencer, and the rest of us pretty much did the building, and we just kind of helped each other, like grab like all the parts that were needed. So, we really worked as a team and kind of came together and did that. So.
How about you guys down here?
Oh, well, we pretty much, we're going to start out as just doing a line following program. Then we realized we could add line, dancing into the line following.
So nobody really told us what this thing's going to do.
They do some spins.
After 20 seconds.
They all do the line follow, and it's just follow the leader. And then at one point they all stop and they do some like few spins. Then they go back and then they turn around and just.
And then we touch the first instance and the rest of them run into each other and end up stopping.
Uniformity is a big part of it when they're all going down.
you're doing exactly the same thing, just in different spots. It's a big part that they're all doing the same thing. Otherwise, they could all cross into each other.
Yeah, like piggybacking on what she said, it's kind of like a marching band, because if the marching band isn't lined up and they're not all in uniform, then it doesn't look so good. So we really stressed that, and we wanted to make sure that they all looked pretty much the same, and that it was all set up in kind of the same way.
Can I get anything else?
That's it.
See it?
Three, two, one, go.
Good job.
A lot of people, some people worked on the programming and some people worked on the building. We wanted this claw at the end because we're kind of sort of going to do the wave. So, not kind of sort of in the beginning, we are.
Okay. What it started out as is first we needed a design, and we went with a really simple design. Then we went with an arm. While people were building the robot and the arm, other people were working on the programming, just the basics. And then once we had all 5 robots built exactly the same, we started to merge together and work on everything.
Once we decided that we wanted to do the wave, we needed something else too. So we liked the idea from Finding Nemo where those fish make all different kinds of designs. So we're going to make a design that's for you guys to find out.
Yeah, and like for the design, when we had all the robots made, the design we made was really hard to kind of predict with just the stuff. So once we had all the robots the same, we used a lot of port view and to try and make sure that things were going the same on each side.
Yeah, I think definitely that was the biggest challenge, was getting them all to go to a perfect spot and having them mostly synchronized.
Well, how did you decide, make decisions as a group, who did what, and how you divide the work up?
In the very beginning, when we took a vote, it was either between line follow, a dance, or
wave or
a wave. So we all took a vote, and it was the wave that got the most votes. So there's 7 of us, and there's 5 robots. So 5 of us all did a robot individually, and then Ryan and Aiden started programming ahead of time so we could get that done first. And then Ethan started working on the arm after we had them all done. And then after they had the programming finished, we just tweaked it to however many seconds we needed to wait it.
In his words, it was pretty much, if someone had an idea, they would execute it and see if it worked or not, and then maybe other people would follow with the idea and help out with that.
Yeah, you get an idea, you check with the team, and then if the team is like, yeah, that's a pretty cool idea, they're looking to you to like show them through it and explain to them how you're doing this and like what you are doing.
All right, make a run.
All one. 3, 2, 1.
So, there we go.